You believe you understand motion. You have watched objects move your entire life. You have thrown balls, pushed carts, walked across rooms. Motion seems as obvious as breathing, so obvious that you have never questioned whether you understand it at all. You are wrong. Not slightly wrong. Not missing subtle details. You are fundamentally, catastrophically mistaken about what motion actually is. Consider what seems most evident. A cart rolls across cobblestones, slows, and stops. A ball thrown upward rises, slows, and falls back to earth. A ship, its sails emptied of wind, drifts gradually to stillness upon the water. In every case, the moving thing returns to rest, as though rest were its home, its natural condition, the state to which all objects aspire when left alone. This appears so self-evident that for 2,000 years, the finest minds of civilization built their entire understanding of nature upon it. Aristotle himself declared it law. Motion requires a mover. Remove the mover, and motion ceases. Rest is the natural state of earthly things, and it is completely, utterly, precisely backward. Watch a child push a toy across the floor. Her small hand propels it forward. It slides, slows, stops. She pushes again. It moves again. She withdraws her hand. It halts. 1,000 repetitions teach her an unshakable lesson. Motion requires pushing. Stop pushing, and motion stops. The lesson seems irrefutable because it is confirmed endlessly, daily, in every interaction with the physical world. But the lesson is a lie. Or rather, it is a profound misreading of what is actually happening. The child has learned to see one actor in a drama that contains two. She perceives her push, but fails to perceive the floor's opposition. The toy does not stop because motion naturally expires. It stops because the floor opposes it at every instant of its slide. Consider, smooth the floor, and the toy travels farther. Polish it to glass, and farther still. Oil the surface, and the toy glides longer yet. The pattern reveals itself, not motion running out, but motion being stolen by friction, being defeated by resistance, being claimed by opposition. The error that Aristotle encoded into Western thought was not mere ignorance. It was the failure to recognize an invisible actor present in every terrestrial scene. Resistance. We live on a planet where friction is omnipresent, where air opposes all movement, where surfaces push back against every sliding object. And we mistook this constant theft for natural law. It is as though you lived in a world of perpetual wind and concluded that all objects naturally drift westward. Now let us examine this more carefully. When a ball rolls across a field and gradually slows, the untrained eye sees motion exhausting itself. The trained eye sees something entirely different, a contest. With every rotation, the grass pushes backward against the ball. With every instant of travel, the air resists its passage. The ball does not give up moving. It is defeated by continuous opposition. The ancients asked, what keeps the arrow flying after it leaves the bow? They invented elaborate theories, the air rushing behind to push it forward, some impressed force gradually expending itself like water draining from a vessel. They laboured mightily to explain how motion could continue without continuous cause, but they asked the wrong question. The correct question is, what stops the arrow? And that question has specific, identifiable answers. Gravity pulls it downward. Air resistance slows its flight. These are the forces demanding investigation, not the motion itself. The arrow needs no explanation for its continued flight. It needs explanation only for its slowing, its curving, its fall. Whence it follows that the entire framework collapses if motion does not inherently expire. If it continues until something stops it, then rest is not the natural state of things. Rest is simply what happens when resistance finally wins. Perform this thought experiment. Imagine a perfectly smooth surface extending infinitely in every direction, suspended in a void without air. Place a ball upon this surface and push it gently. Release it. To what destination does it proceed? At what point does it remember to stop? At what distance does motion run out? The answer is never, nowhere. The ball proceeds forever at whatever speed you gave it, in whatever direction you aimed it, without slowing, without curving, without stopping. Not because some force sustains it, but because nothing opposes it. This reveals the truth concealed by our friction-filled world. Motion requires nothing to sustain it. Only opposition can end it. Strip away resistance, and what remains? Motion that continues forever. Not because something propels it, but because nothing stops it. The consequences of this error extend far beyond physics. For 2 millennia, humanity believed that rest is free and motion is costly, that stillness requires no explanation and movement demands perpetual justification, that the natural state of things is stagnation and all change is a temporary deviation from the universal tendency toward inactivity. Consider how this shapes thought. If motion requires continuous cause, then any endeavor must be continuously pushed or it will stop. You must forever justify continuation. The burden of proof lies always with action, never with inaction. But this is not merely wrong about falling stones and rolling spheres. It is wrong about everything. You have been watching motion your entire life. You have been misreading it just as long. What you saw as objects naturally stopping was objects being stopped. What you interpreted as motion running out was motion being stolen. The thief was always there. You simply never saw it. Now you begin to see. And this changes everything that follows. But if rest is not the natural state of things, and motion does not inherently expire, then we must confront an even deeper error, an assumption so fundamental it has shaped 20 centuries of thought. What if motion and rest are not opposites at all? What if they are not even different states? This is the error we must now expose. Here is the assumption that governed human understanding for 2 millennia. Motion is a deviation from rest. Rest is basic. Rest is natural. Rest simply is. Motion, by contrast, is something that happens to a resting object, a temporary disturbance requiring continuous cause, always seeking to return to the stillness from which it came. Aristotle taught this, the medieval scholars elaborated it, the common sense of every person who has ever lived seems to confirm it. When you stop pushing, things stop moving. When effort ceases, stillness returns. Motion is the anomaly. Rest is the norm. And it is precisely, completely, catastrophically wrong. Motion and rest are not opposites. They are not even different states. A body moving at constant speed in a straight line and a body perfectly still are in identical conditions, both persisting without cause, both requiring nothing to maintain them, both changing only when forced to change. This is the hardest thing to grasp. Let us proceed carefully. Stand within a ship's cabin on calm seas. The ship moves steadily through the water at constant speed. Inside the cabin, you cannot tell. Drop a ball from your hand. It falls straight down, exactly as it would if the ship were anchored in harbour. Your breakfast sits undisturbed upon the table. The candle flame burns upward. Your companion's voice reaches your ear at normal speed. Nothing within that cabin reveals whether you move or rest. This is not a limitation of your senses. This is not a practical difficulty that better instruments might overcome. This is fundamental truth about the nature of reality. No experiment you can perform within that cabin, no measurement, no observation, no test of any kind will reveal whether the ship moves at 10 leagues per hour or sits motionless at anchor. The phenomena are identical. The conditions are indistinguishable. And this is because uniform motion and rest are the same state. Not equivalent for practical purposes, not similar enough to ignore the difference. The same state. There is no difference to ignore. The distinction between uniform motion and rest is not a fact about the moving body. It is merely a description of the body's relationship to some other reference point. Consider what this demolishes. The ancients believed celestial objects moved eternally because such motion was natural to heavenly matter, while earthly objects sought rest because rest was their natural state. Two substances, two sets of rules, two physics, one for the heavens and one for the ground beneath your feet. But there is no such division. There is no special celestial matter. The moon does not float in the heavens, exempt from earthly laws. The moon obeys the same principles as the stone in your hand, and those principles do not privilege rest over motion. A body at rest remains at rest. A body in uniform motion continues in that motion, in a straight line, at constant speed, forever. These are not two laws. They are one law with two expressions. Neither state requires cause. Neither state requires explanation. Neither state is more natural than the other. Only change requires force. Let this sink in, for it inverts everything you thought you knew. You do not need to explain why a moving body keeps moving. You need to explain only why it would stop. And the explanation will always involve some force acting upon it. Friction, resistance, gravity, collision. You do not need to explain why a resting body stays at rest. You need to explain only why it would move, and the explanation will always involve some force acting upon it. A push, a pull, an attraction, an impact. The questions, why does it keep moving, and why does it stay still, are identical questions with identical answers, because nothing is compelling it to change. Persistence requires no cause. Change requires cause. This is the principle that governs all motion in the universe. Now imagine waking in a void, far from any visible object. No stars, no ground, no reference of any kind. You float in darkness. Are you moving or at rest? The question has no answer. Not because you lack information. Not because the answer is hidden or difficult to determine. The question has no answer, because without reference to other objects, the distinction between motion and rest has no meaning. They are not different kinds of being. They are not different states of existence. They are merely different descriptions of relationship. The ship moves relative to the shore and rests relative to the cabin floor. You move relative to the spinning earth and rest relative to the chair beneath you. The earth moves relative to the sun but relative to what does anything truly rest. There is no anchor point in the cosmos. There is no place of absolute stillness against which all motion can be measured. Motion and rest are always relative. They are always descriptions of relationship. And relationships between objects tell us nothing about the objects themselves, only about their arrangement. Whence it follows that the burden of explanation shifts completely. You never needed to ask why a moving object continues moving. You should have asked only, what would stop it? And when you ask that question, you discover that the answer is always some force, friction, resistance, gravity, collision, always a specific, identifiable cause. You never needed to ask why a resting object remains at rest. You should have asked only, What would move it? And when you ask that question, you discover the same answer. Some force. A push, a pull, an attraction. Always a specific, identifiable cause. The universe does not distinguish between rest and uniform motion. Neither should you. What the universe distinguishes, sharply, precisely, invariably, is between states that persist and states that change. Persistence is free. Change costs force. This is the principle. Every body continues in its state of rest or of uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. Read it again. It is not two principles glued together. It is one principle with one meaning. States persist until changed. Whether that state involves motion or stillness is irrelevant to the principle. Both persist equally. Both require nothing to maintain. Both change only when forced to change. For 2,000 years, humanity asked the wrong question. We asked, what keeps things moving? When we should have asked, what changes things? The first question assumes motion is unnatural and requires justification. The second question recognizes that change, all change, whether from rest to motion or motion to rest, is what requires explanation. Now you know the right question to ask, and this prepares the ground for what we must examine next. If change requires force, what exactly is force? What happens when a body's state changes? We must understand force not as the cause of motion, but as something quite different. Here is the error that persists even after the first two are corrected. People believe force causes motion. It does not. Force causes change in motion. The distinction sounds subtle. It is not. It transforms everything. Consider the horse pulling a cart. Common understanding says the horse's force causes the cart to move. But examine more carefully. Does the horse cause the cart to move? Or does the horse cause the cart to accelerate, to change from rest to motion, from slow to fast? If the horse pulls steadily on a smooth road, the cart speeds up. What happens when the cart reaches a constant speed? The horse keeps pulling, but the cart stops accelerating. It moves at steady pace, neither speeding up nor slowing down. Has the horse's force vanished? No, the horse still pulls. But other forces now balance that pull. Friction in the axles, resistance of the air, roughness of the road. The forces cancel. No net force means no change. The cart continues at constant speed without needing force to maintain it. Now imagine the impossible. The horse vanishes and the road becomes perfectly smooth and frictionless. What happens to the cart? It continues forever at whatever speed it had reached. Not because some force sustains it, because no force opposes it. The horse's force was never needed to maintain the cart's motion. The horse's force was needed only to change the cart's state, to accelerate it against friction's opposition. Remove friction, and the cart needs no horse to keep moving. Force is the agent of change, not of motion. Let us establish this with precision. Place a stone upon a table. It rests perfectly still. Does this mean no forces act upon it? Not at all. Enormous forces act upon it. Gravity pulls it downward with considerable strength, and the table pushes upward with exactly equal strength. The forces are vast. They merely cancel. When forces balance, they might as well not exist, so far as motion is concerned. The stone continues in its state, which happens to be rest, because the net force is zero. No net force, no change of state. Now push the stone sideways. You add a force in a direction where nothing opposes it, or at least where opposition is less than your push. The force is no longer balance. A net force exists, and the stone accelerates in the direction of that net force. The moment you cease pushing, friction begins to dominate. The stone decelerates. It slows until it stops. You might describe this as the stone losing its motion. But the stone has lost nothing. Something has been taken from it. Friction impressed a force opposite to its motion and changed its state from moving to rest. At every instant, what you observe is the result of all forces combined. Where they balance perfectly, no change occurs. Where they do not balance, change occurs. And the direction of change is always the direction of the net force. This is why objects fall. A stone held in your hand experiences two forces: gravity pulling down, your hand pushing up. They balance. The stone stays still. Release your grip, and suddenly only one force acts: gravity. The stone accelerates downward, not because down is its natural destination, not because it seeks the earth, but because an unbalanced force acts upon it in that direction. The stone accelerates at precisely the same rate, whether it was previously at rest or already moving sideways. Gravity does not care what the stone was doing before. Gravity simply adds its effect, a constant acceleration downward to whatever other motion the stone possesses. This is why a ball thrown horizontally curves downward in a parabolic arc. Two independent phenomena occur simultaneously. The ball continues forward at constant speed because no horizontal force opposes it significantly, while it simultaneously accelerates downward because gravity pulls it. The combination produces the curve. Neither motion affects the other. The ball would travel just as far forward whether gravity existed or not. It would fall just as fast whether moving sideways or not. Forces do not cause motion. Forces change motion, and multiple forces acting together combine their effects mathematically, each one adding its own change to whatever state the body already possesses. Observe this in your own experience. When you walk, you push backward against the ground with each stride. The ground pushes you forward in response. This forward push accelerates you. It changes your state from slower to faster. Once you reach a steady walking pace, you continue pushing only to overcome the resistance of air and the imperfection of your gait. You do not push yourself to maintain forward motion. You push only to counteract the forces that would otherwise slow you. Notice what happens on ice. The ice offers little friction. You cannot push effectively against it. Therefore, you cannot accelerate forward. But equally, once moving on ice, little friction acts to slow you. You glide farther with each push. The same principle operates in both directions. Where friction is low, change is difficult to produce, whether you want to speed up or slow down. Or consider a pendulum. At the top of its swing, it pauses momentarily, velocity zero, before falling back. At the bottom of its swing, it moves fastest. What changes its motion? Gravity, pulling always downward. When the pendulum moves horizontally, gravity's downward pull is perpendicular to the motion and changes direction, but not speed. When the pendulum moves up or down, gravity's pull either opposes or assists the motion and changes speed accordingly. Every phenomenon you observe, from the fall of a leaf to the orbit of the moon, results from forces changing states of motion. No force maintains any motion. Force is exclusively the agent of change. Here is the key to unlock all mechanical understanding. When you see motion changing, look for force. When you see motion persisting unchanged, look for balanced forces or no force at all. The universe operates by this principle absolutely, without exception, everywhere and always. The horse does not make the cart go. The horse changes the cart's state against opposing friction. The falling stone is not seeking the ground. The stone is accelerating under unbalanced gravitational force. The arrow flying through the air is not being maintained by anything. The arrow is being slowed by air resistance and pulled downward by gravity. Two forces changing what would otherwise be eternal, straight-line motion. Force produces change. Persistence requires nothing. This reframes entirely how you understand effort, action, and the operation of the physical world. But a question emerges from this understanding. If force causes change, and change is proportional to force, why do different objects respond differently to identical forces? Push a feather, and it flies. Push a cannonball with identical force, and it barely budges. The same force, vastly different effects. What property of matter determines how much an object resists change? This is what we must examine next. The nature of resistance itself. Consider two balls resting upon a table, one small and light as a child's toy, one large and heavy as a cannonball. Push both with identical force. The light ball flies across the table. The heavy ball barely shifts. The common explanation is that the cannonball wants to rest more than the toy does, that heaviness creates a greater affinity for stillness. But this explanation fails a simple test. Set both balls rolling at equal speed and then try to stop them. The toy halts easily. The cannonball requires enormous effort to intercept. If heavy objects wanted to rest, stopping them should be easier than starting them. But it is not. It is equally difficult. Heavy objects resist all change, starting, stopping, speeding up, slowing down, turning, with equal stubbornness. This reveals the true nature of what resists force, not a preference for rest, but a resistance to change itself. And this resistance is proportional to something we call mass, the quantity of matter a body contains. Mass is the measure of a body's resistance to change in motion. The more mass, the more force required to produce the same change. This can be stated precisely. Acceleration equals force divided by mass. Double the force applied to a body, and you double its acceleration. Double the body's mass, and you halve its acceleration. The relationship is exact, mathematical, invariable. Notice what this does not say. It does not say heavy objects prefer stillness. It does not say mass opposes motion. It says mass opposes change in motion. Any change, in any direction, whether the body is currently moving or at rest. A cannonball at rest and a cannonball moving at great speed possess identical resistance to change. The resistance depends only on the quantity of matter, not on the current state of motion. This is why bringing a moving cannonball to rest requires exactly as much force as setting a resting cannonball into motion at the same speed. This property, this resistance to change, is what we properly call inertia, and it operates symmetrically in all directions, for all changes, regardless of the body's current state. Now observe how this resolves an apparent puzzle. Drop a feather and a cannonball from the same height. The cannonball reaches the ground first. Does this prove that heavier objects fall faster? Aristotle thought so. He taught that heavier bodies fall more rapidly because they have greater heaviness pulling them earthward. But consider, if we could remove the air, perform the experiment in a void, what would happen? The feather and the cannonball would reach the ground at precisely the same instant. The difference we observe is not in how gravity acts, but in how air resistance acts. Gravity pulls the cannonball with greater force, but the cannonball resists acceleration more because it has more mass. The extra force exactly compensates for the extra resistance. The ratio cancels. In a void, all objects accelerate downward at identical rates, regardless of mass. The feather falls more slowly only because air resistance, a fixed opposition based on size and shape, slows it proportionally more than it slows the dense cannonball. The feather's small mass means small gravitational pull, but also small resistance to the slowing effect of air. The cannonball's large mass means large gravitational pull, but also large resistance to air's slowing. In air, these different ratios produce different speeds. In vacuum, the ratios equalize. Inertia opposes change. Gravity produces change. They are different phenomena operating by different principles. Now consider what this means practically. When a horse-drawn carriage halts suddenly, the passengers lurch forward. Their bodies were moving with the carriage. When the carriage stops beneath them, their bodies continue forward. This is not because their bodies want to keep moving. This is because their bodies resist the change imposed by the stopping carriage. Their inertia carries them forward until friction with the seat, collision with the front wall, or their own grip arrests their motion. You feel inertia every time a vehicle changes speed or direction. When the vehicle accelerates, your body is pushed back into the seat, your body resists the acceleration and lags behind. When the vehicle turns, your body continues in the original direction until the seat pushes you around the curve. When the vehicle stops, your body continues forward until something arrests it. In every case, what you feel is not force, but resistance to force. Your body's inertia opposing the change being imposed upon it. The quantity of matter in a body determines how stubbornly it resists change. A laden cart requires more force to start moving than an empty one, not because the laden cart prefers rest, but because more matter must be accelerated. The same laden cart, once rolling, requires more force to stop. Same principle, opposite direction. This is why it hurts to catch a heavy ball thrown at speed and barely registers when you catch a light one at the same speed. Both balls change from moving to rest when you catch them. The heavy ball's greater mass means greater resistance to this change, and that resistance manifests as greater force against your hands during the brief moment of stopping. Inertia is real. It is measurable. It is universal. And it operates identically whether a body is speeding up, slowing down, or changing direction. Mass resists all change equally. But now another question presents itself. We have established that force changes motion and mass resists change. But what of the body doing the pushing? When you push a cart, you feel the cart push back. When you throw a ball, you feel yourself recoil. Does force flow in one direction only, or does something flow back? This is the question of reciprocity, and its answer reveals something profound about the nature of all interaction. Stand upon a small boat resting at a dock. Step off the boat onto the dock. As you push against the boat to propel yourself forward, watch what happens. The boat moves backward. Your push against the boat propels you forward. The boat's push against you propels it backward. These are not two separate events. They are one event viewed from two perspectives. You cannot push without being pushed in return. This is universal. Every force in nature involves two bodies, and every force has an equal and opposite companion acting on the other body. When you push a wall, the wall pushes you. When the earth pulls an apple downward, the apple pulls the earth upward. The forces are always matched, precisely, instantly, necessarily. To every action, there is always opposed an equal reaction. But wait, if the apple pulls the earth upward with the same force that the earth pulls the apple downward, why doesn't the earth move? It does move. The forces are equal, but the masses are not. The apple accelerates visibly because its mass is small. The earth accelerates imperceptibly because its mass is enormous. Push a ball and it flies. Push a boulder with the same force and it barely shifts. The forces are identical. The effects differ because the masses differ. The earth accelerates toward every falling apple, every leaping person, every launched cannonball. The accelerations are simply too small to detect. When you jump, you push the earth downward, and the earth pushes you upward. The forces are equal. Your acceleration is obvious. The earth's acceleration is immeasurably tiny, but it occurs. This is why we do not notice the reciprocal nature of most forces. We interact primarily with objects far lighter than ourselves, balls, tools, furniture, and we rarely notice our own recoil because friction with the ground absorbs it. Only in special circumstances, standing on ice, floating in water, pushing off from a boat, does the reciprocity become obvious. But it is always there. The universe permits no one-way forces. Consider the cannon. When a cannon fires, the ball accelerates forward at tremendous speed, but the cannon itself accelerates backward, the recoil that must be absorbed by its carriage and mounting. The same force that propels the ball forward propels the cannon backward. The ball travels far because its mass is small. The cannon recoils less because its mass is large. But the forces are identical. This is not coincidence or peculiarity of cannons. This is universal law. Every time force acts between two bodies, equal forces act on both in opposite directions. The effects differ only because the masses differ. When you throw a ball, your body recoils backward. On firm ground you do not notice because friction with the earth absorbs the recoil. On ice, you would slide backward as the ball flies forward. In a boat, the boat would move backward beneath you. The recoil is always there. The equal and opposite reaction is always there. Only circumstances determine whether you notice it. This principle resolves a puzzle that seems to contradict what we have established. When a horse pulls a cart, the horse moves forward, and the cart moves forward with it. But if every action has an equal and opposite reaction, doesn't the cart pull backward on the horse with equal force? And if the forces are equal, how does anything move at all? The error is in analyzing isolated pairs rather than complete systems. Yes, the horse pulls the cart forward, and yes, the cart pulls the horse backward with equal force. These forces are internal to the horse-cart system. They cannot, by themselves, accelerate the system as a whole. What moves the system? The horse pushes backward against the ground, and the ground pushes forward against the horse. This external force from the ground accelerates the entire horse-cart system forward. The horse is a mechanism for transmitting force from the ground to the cart, not the ultimate source of forward force. The ground does not move noticeably because the Earth's mass is enormous, but the Earth does accelerate backward infinitesimally when the horse pushes against it. Equal and opposite, always. Place two balls on a smooth table, one heavy, one light, touching each other. Push the heavy ball toward the light one. When they collide, the heavy ball slows and the light ball accelerates. During the collision, each ball exerts force on the other. The forces are equal and opposite. This is not speculation, but necessity, built into the nature of force itself. But equal forces do not produce equal accelerations. The light ball, with less mass, accelerates more. The heavy ball, with more mass, accelerates less. Watch carefully, and you see the exchange. Motion transfers from the heavy ball to the light one. But the forces during transfer are always equal. The asymmetry of effect comes entirely from the asymmetry of mass. This is why collisions between unequal masses seem one-sided. A cart striking a pebble sends the pebble flying while barely affecting the cart's motion. But the forces were equal. The pebble pushed back on the cart exactly as hard as the cart pushed the pebble. The pebble's small mass made its acceleration enormous. The cart's large mass made its acceleration negligible. Now we see the complete picture of mechanical interaction. Force causes change in motion. Mass resists change. And every force involves mutual exchange, equal forces acting on both interacting bodies, producing unequal effects only because masses differ. You cannot push without being pushed. You cannot pull without being pulled. The universe is a web of reciprocal interactions, every force met with its opposite, every action producing reaction. The asymmetries we observe are not asymmetries of force, but asymmetries of response, differences in how bodies react to equal forces based on their different masses. This changes how you perceive every interaction. When you push open a door, the door pushes back on your hand with exactly the force you exert, and you stop pushing when that force becomes uncomfortable, long before you damage your hand. When you lift a weight, the weight pulls down on you exactly as hard as you pull up on it, and you feel that pull through your arms and shoulders. When you walk, you push the earth backward, and the earth pushes you forward. Equal forces producing enormously unequal effects. The reciprocity is always there. The equality is always exact. The universe permits no exception. We have now established the foundations. States persist until changed. Force is the agent of change. Mass resists change. And all forces involve mutual, equal exchange. These principles govern the falling of leaves and the motion of carts. But one force remains mysterious. One force reaches across the void without contact, acting at a distance in ways we have not yet examined. The same force that holds your feet to the ground reaches across hundreds of thousands of leagues to grasp the moon and bend its path. The same force that drops an apple from a branch pulls the tides across the seas and holds the planets in their courses. We must now examine this force and discover that it unifies heaven and earth in a single, comprehensible system. Look up at the moon. That pale disk floating in the darkness seems utterly remote from the world beneath your feet. It hangs in the heavens, serene and separate, following its ancient path through the sky. For thousands of years, humanity believed celestial objects existed in a realm apart, made of different substance, following different rules, exempt from the forces that govern earthly things. This belief is wrong. The moon is not floating. The moon is not exempt from earthly force. The moon is falling. At this very moment, the moon is falling toward the earth. It has been falling since it first began its circuit, and it will continue falling as long as it orbits. The same gravity that pulls an apple from its branch reaches across 200,000 leagues of void and pulls the moon toward the earth with relentless, continuous force. But if the moon is falling, why does it not crash into the earth? Because it is also moving sideways, and it is moving sideways fast enough that as it falls toward the earth's surface curves away beneath it. The moon falls and falls and falls, but the target keeps receding. It falls around the earth rather than into it. The moon is a stone thrown so fast that it misses the ground forever. Consider a cannon mounted on a high mountain peak, firing horizontally, fire with little powder, and the ball curves downward, striking the ground nearby. The ball moves forward while simultaneously falling, two motions occurring together. neither affecting the other. The forward motion continues at constant speed, ignoring air resistance. The downward motion accelerates under gravity. Combined, they produce a curving path that ends when the ball meets the ground. Now increase the powder. The ball travels faster horizontally, covering more distance before gravity pulls it to the ground. It lands farther away. The curve is longer, shallower, but still a curve, still ending at the surface. Increase the powder again, and again. Each time the ball travels farther before striking the ground. The curve stretches longer. Now consider, the Earth is not flat. The Earth's surface curves away beneath the flying ball. As the ball falls toward the surface recedes downward. Fire with sufficient force, and something remarkable occurs. The ball falls toward the Earth, but the Earth curves away at precisely the rate the ball falls. The ball is always falling, always approaching the surface, yet never reaching it. The curve of its fall matches the curve of the Earth. The ball orbits. This is not metaphor. This is precise description of what orbital motion actually is. An orbit is a fall that perpetually misses its target. The moon does not float in the heavens. The moon falls continuously, its sideways motion converting that eternal fall into a circuit around the Earth. The same gravity that operates at the Earth's surface reaches to the moon. This is not analogy. This is identical force. The apple and the moon are pulled by the same attraction, obeying the same law, differing only in distance and in the presence or absence of sideways motion. Calculate the rate at which the moon falls toward the Earth, the deviation from a straight line path that gravity produces each second. Compare this to the rate at which an apple accelerates when dropped. Account for the moon's distance, approximately 60 times the radius of the Earth. Apply the inverse square law. Gravity weakens with the square of the distance. The numbers match precisely. The moon, 60 times farther from the Earth's center than an apple on its surface, experiences gravity approximately 3,600 times weaker, 60 squared. And the moon's deviation from straight line motion is precisely what this weakened gravity predicts. The mathematics are exact. The correspondence is perfect. One gravity, one law. Heaven and earth unified in a single, comprehensible system. But gravity does not stop at the moon. Every body in the universe attracts every other body. The book upon your table pulls the ceiling above it, and the ceiling pulls the book. The force is minuscule, masses so small, and distances so modest produce attractions too faint to detect. But the attraction exists. It must exist. The law is universal. The sun attracts the earth across 90 million miles of void. The earth attracts the sun with equal force. The sun, vastly more massive, barely moves. The earth, vastly less massive, swings around in an annual orbit, falling toward the sun perpetually, its orbital speed preventing it from ever arriving. Jupiter attracts Saturn. Saturn attracts Jupiter. Both attract the sun and are attracted by it. Every planet tugs on every other planet, producing subtle variations in their orbits, variations that can be calculated and predicted using the single law of universal gravitation. Comets sweep in from the distant reaches of the cosmos, arc around the sun in elongated ellipses, and return to the depths from which they came. They follow no special rules. They obey the same gravity that governs falling apples. Their paths can be predicted, their returns calculated, because the law is universal and the mathematics precise. Stand at the seashore and watch the tide come in. The waters do not rise through mystical sympathy with the moon. They are pulled. The moon's gravity reaches across the void and attracts the ocean, more strongly on the near side of the Earth, less strongly on the far side. The water bulges toward the moon on the near side and bulges away because the Earth is pulled more strongly than the far side water on the opposite side. As the Earth rotates beneath these bulges, coastlines experience the rise and fall we call tides. The same force that drops an apple from a tree pulls the ocean toward the moon. The same force that holds the moon in orbit raises the waters twice daily. One law explains both phenomena and countless others besides. This is the vision that replaces the ancient division of heaven and earth, a unified cosmos, every part connected to every other part through the invisible web of gravitational attraction. There is no special celestial matter. There are no divine spheres carrying the planets in their courses. There are bodies, masses of matter, moving through space, each one pulling on every other, each one falling toward every other, all motion resulting from this universal mutual attraction. The elegance of this arrangement cannot be accident. That one principle should govern phenomena so apparently different, the apple and the moon, the tides and the comets, the fall of a raindrop and the orbit of Saturn, reveals a universe constructed on intelligible foundations. The cosmos is not chaos decorated with lights. It is a vast machine operating by comprehensible rules, rules we can discover, express mathematically, and apply to predict phenomena we have never observed. But to fully grasp what has been revealed, we must see the unification complete. We have shown that celestial objects fall like earthly ones. Now we must understand what this means. There is one physics for all the universe, one set of laws, one unified system of nature. This is what we examine next. For 2,000 years, philosophers taught that the heavens and the earth obeyed different rules. The heavens were perfect, unchanging, made of crystalline spheres and ethereal substance. Celestial objects moved in eternal circles because circular motion was natural to them, requiring no explanation, no cause, no force. The earth was corrupt, changeable, made of base matter that sought rest and resisted motion. Two realms, two physics, two sets of laws. This division was not arbitrary. It seems to follow from observation. Nothing on earth moves forever. Celestial objects never stop. Nothing on earth moves in perfect circles. Celestial paths appear perfectly circular. The heavens and the earth seemed fundamentally different, but they are not. The planets do not move in circles because circular motion is natural to them. They move in ellipses because gravity bends their paths. They would move in straight lines if no force acted, just like any earthly body. Gravity provides the force that curves their paths, pulling them always toward the sun, bending what would be straight-line motion into closed orbits. Remove gravity, and the planets would fly off into the void, moving in straight lines forever, just as a stone would if you could remove all forces acting upon it. There is no special celestial substance. There is no natural circular motion. There are bodies obeying the same laws that govern everything else. The same mathematics describes a ball thrown across a field and a planet orbiting the sun. Consider a ball thrown horizontally. It moves forward at constant speed while accelerating downward under gravity. The combination produces a parabolic curve. Where the ball lands depends on its initial speed and the height from which it was thrown. The mathematics are precise, the predictions exact. Now consider a planet orbiting the sun. It moves sideways, tangent to its orbit, while accelerating inward under gravity. The combination produces an elliptical curve. The shape of the ellipse depends on the planet's speed and its distance from the sun. The mathematics are identical in principle, only the scale differs. A thrown ball traces a section of an ellipse. It simply hits the ground before completing the curve. An orbiting planet traces the complete ellipse because nothing interrupts its fall. The same equations govern both phenomena. The same force produces both curves. The same principle unifies the terrestrial and the celestial. This uniformity cannot be accident. That one law should explain why apples fall from trees and why Jupiter takes 12 years to orbit the Sun. This is not coincidence. That the same mathematics should predict the arc of a cannonball and the return of a comet. This speaks to the intelligible structure of nature itself. Comets were once thought to be omens, signs, portents of disaster or divine intervention. Their appearances seemed random, inexplicable, outside the ordinary course of nature. But comets follow the same law as everything else. Their orbits are simply very elongated ellipses. A comet that appeared in the sky generations ago will return at a time that can be calculated, not through prophecy, but through mathematics. The tides were once attributed to mystical sympathy between the moon and the waters. But tides are gravitational effects, predictable and calculable. The waters rise and fall in patterns that follow directly from the moon's position and the geometry of coastlines. No sympathy required, only universal gravitation and precise mathematics. Now we see the full picture. Every body attracts every other body with a force proportional to their masses and inversely proportional to the square of the distance between them. This single statement, this one law, explains an astonishing range of phenomena. Why does the moon orbit the Earth? Because gravity pulls it inward while its motion carries it around the curve. Why do the tides rise and fall? Because the moon's gravity pulls on Earth's waters. Why do the planets trace ellipses around the sun? Because gravity from the sun curves their straight-line paths into closed orbits. Why does a dropped stone accelerate toward the ground? Because Earth's gravity pulls it with a force that produces acceleration. Why does a cannonball trace a parabolic arc? Because it moves forward at constant speed while simultaneously accelerating downward under gravity. One law, countless applications, the division between heaven and earth abolished. But observe what this does not explain. We have established how gravity operates, the mathematical law it follows, the effects it produces. We have not established why it operates. We have not discovered the mechanism by which one body reaches across empty space to attract another. We have not explained how the sun knows where the earth is, or how the earth feels the sun's attraction across 90 million miles of void. The effects are plain. The mathematics are exact. The cause remains hidden. This is not failure, it is honesty. We can describe what gravity does with perfect precision. We can predict its effects with complete accuracy. We can unify terrestrial and celestial mechanics under one law. But the underlying mechanism, how matter acts upon matter at a distance, remains a mystery. I frame no hypothesis, one might say. The cause of gravity is what we do not pretend to know, but its effects are manifest, and those effects reveal a universe of elegant, intelligible order. We have journeyed from the exposure of error through the establishment of principle to the vision of cosmic unity. The laws we have examined govern the fall of apples and the orbits of planets with equal precision. One question remains. What does this understanding mean for how we perceive and live? How does this transform not merely our knowledge, but our daily experience of the world? This is what we must explore as we complete our journey. The knowledge we have gained is not merely intellectual. It transforms perception itself. Where before you saw objects resting or moving, now you see forces in continuous contest. Where before you saw stillness as the absence of action, now you see it as the balance of enormous powers. The world has not changed, but your eyes have. Stand perfectly still. Feel your weight pressing into the floor beneath you. What you feel is not merely your body's mass. What you feel is the conflict of forces, gravity pulling you downward toward the center of the earth, the floor pushing upward with exactly equal strength. These forces are enormous. They merely cancel. If the floor suddenly vanished, if the upward push disappeared, you would feel the change instantly. Gravity would no longer be opposed. You would accelerate downward. You would fall. This is what weightlessness actually is. Not the absence of gravity. Gravity reaches everywhere, but the absence of the opposing force. An object in free fall experiences gravity fully. It simply has nothing pushing against gravity. Everything in the falling object accelerates together, and there is no internal conflict to feel. The astronaut floating in orbit is not beyond gravity. The astronaut is falling, continuously falling toward the Earth as the moon does. The astronaut feels weightless, not because gravity has ceased, but because everything around the astronaut falls at the same rate. There is no floor pushing upward, no resistance to the fall, just perpetual falling in perfect balance with orbital motion. Now walk across a room. Notice what you actually do. With each step, you push backward against the floor. The floor pushes forward against you. Equal and opposite reaction. This forward push accelerates you, overcoming the small resistance of air and maintaining your steady pace. Between steps, your forward motion continues, not because you sustain it, but because nothing stops it. You coast between pushes exactly as a ball coasts on a smooth surface. Your effort goes entirely into overcoming resistance and adjusting your state, not into maintaining forward motion. Now stop walking. What stops you? Friction with the floor, deliberate backward pushing with your feet, air resistance. You do not stop trying to move. You impose forces opposite to your motion until your velocity reaches zero. Then you persist at rest, just as you persisted in motion, requiring nothing to maintain either state. Every moment of every day, you experience these principles. You simply never saw them before. Now, you cannot unsee them. Watch water poured from a vessel. The stream of water does not want to flow downward. The water is pulled by gravity and opposed by nothing sufficient to stop it. Each droplet accelerates as it falls, following the same parabolic path a thrown stone would follow in reverse. The water seeks nothing. It simply responds to the forces acting upon it. When the water lands in a basin and spreads to stillness, it has not achieved rest or found its level. The forces have balanced, gravity pulling downward, the basin pushing upward, surface tension constraining the edges. Where forces balance, motion ceases. Where they do not balance, motion continues until they do. A river carving its channel over centuries follows the same law as the moon orbiting the earth. Gravity pulls the water downward. The riverbed constrains its path. Rocks and bends create resistance that shapes the flow. Over time, the water cuts through soft stone and accumulates sediment, sculpting the landscape through countless small applications of force over vast spans of time. Nothing in the river seeks the sea. Forces act, matter responds. The pattern we call a river emerges from the accumulation of lawful interactions. Look at an arch of stone. Why does it stand? Each stone pushes against its neighbours, transmitting the weight of the structure down and outward to the foundations. The forces are enormous, tons of stone pressing in all directions, but they balance. Remove one stone and the balance collapses. The forces no longer cancel. The arch falls. The arch does not want to stand. The arch stands because the forces happen to balance in that particular arrangement. Change the arrangement and the forces may not balance. The arch is not a thing with purpose. It is a pattern in which forces achieve equilibrium. Once you see this, you see it everywhere. The tree leaning in the wind, gravity pulling down, roots anchoring below, wind pushing sideways, forces in dynamic balance, the tree's angle revealing the net effect. The suspension bridge, cables in tension pulling upward, deck pushing down, towers transmitting forces to the earth, a web of balanced forces creating the appearance of solidity in what is actually a system of controlled opposition. Feel the ground beneath your feet. The same force that holds you there reaches across the void to hold the moon in orbit. The same law that governs your weight governs the tides. You stand at this moment within a web of gravitational attraction that extends to the farthest reaches of the cosmos. Every particle of your body attracted to every particle of the earth. Every particle of the earth attracted to every particle of you. Every particle of everything attracted to every particle of everything else. The forces are mostly negligible. Your attraction to the book across the room, to the tree outside, to the moon above, but they exist. They must exist. The law permits no exceptions, acknowledges no boundaries, respects no distances. Where there is matter, there is gravitational attraction. You are connected to the moon, to the sun, to the stars themselves, not through mystical sympathy, but through the plain operation of universal law. The cosmos is one system, and you are part of it. This is what it means to see forces everywhere. The book on the table, gravity pulling down, table pushing up. The bird in flight, gravity pulling down, air pushing up and forward, wings adjusting the balance moment by moment. The spinning top, gravity pulling toward its center, angular motion resisting the tilt, friction gradually stealing the spin until the balance fails and the top falls. The world was always this way. You simply never saw it clearly. Now the invisible becomes visible. The static reveals itself as dynamic. Every apparent stillness unmasks itself as a balance of forces, and every motion reveals the imbalance that produces it. You have learned to see forces. Now you must learn to think correctly about what you see, to ask the right questions and place the burden of explanation where it properly belongs. We have arrived at the transformation that outlasts all the others. You have learned that motion and rest are equivalent states. You have learned that force causes change, not motion. You have learned that mass resists change, that forces are always mutual, that gravity unifies heaven and earth. These are facts you can now observe, principles you can apply, truths that reshape how you see every phenomenon. But the deepest change is not in what you know, it is in what you ask. When an endeavor falters, the common question is, why did it stop going? This question assumes motion is unnatural. It assumes continuation requires justification. It places the burden of explanation on persistence rather than on change. And because it assumes the wrong thing, it leads to useless answers, vague urgings to try harder, generic complaints about losing momentum, empty advice to stay motivated. But motion does not require motivation. Persistence requires nothing. The right question is, what is resisting it? This question assumes that continuation is natural. that whatever persists will continue to persist until something stops it. It places the burden of explanation on change, where it properly belongs. And because it assumes the right thing, it leads to useful answers, specific identification of the obstacles, particular analysis of the opposition, targeted understanding of what force is stealing progress. The questions are not equivalent. The first closes investigation with platitudes. The second opens investigation with precision. When a ball rolling across a field slows and stops, the wrong question is, why did it stop rolling? The right question is, what stopped it? And the answer, friction with the grass, resistance from the air, is specific, identifiable, and explanatory. When a pendulum gradually stills, the wrong question is, why did it stop swinging? The right question is, what stole the swing? And the answer, air resistance claiming a little motion with each pass, points precisely to the cause. When any project, any endeavour, any change in circumstances falters, the same principle applies. Do not ask why the motion expired. Ask what force opposes it. The question transforms investigation from vague to precise, from hopeless to actionable. Now consider persistence from this new perspective. You do not need to justify continuation. What continues, continues because nothing stops it. The burden of explanation lies entirely upon change. This liberates you from the false obligation to perpetually defend ongoing states. A river does not need to justify flowing. It flows because gravity pulls, and nothing sufficient opposes. When the river stops, at a dam, at the sea, at a dry season, that requires explanation. What force or circumstance has changed the balance? A habit does not need continuous motivation to persist. Once established, it continues because the pattern has been set and nothing disrupts it. When a habit breaks, that requires explanation. What opposing force has intervened? This reframes how you think about maintenance and change. You need not waste effort maintaining states that require no maintenance. You need only apply force where change is desired, or remove opposition where persistence is desired. The economy of force becomes clear. Act only where action is needed. Rest is free. But here is the distinction that cuts through endless confusion. Learn to separate true persistence from continuous change. A stone resting on a table persists without any cause. Nothing sustains it. It simply remains in its state until something compels change. This is true persistence. A flame burning on a candle does not persist in the same way. The flame appears to maintain its state, but it is continuously transforming fuel into heat and light and ash. The flame is not persisting, it is perpetually becoming. It requires continuous supply of fuel and air to continue existing. Remove either, and the flame does not persist at rest. It vanishes. The orbit of a planet appears to persist indefinitely, but it too is continuous change. The planet's direction changes constantly as gravity bends its path. The orbit is not a state that persists. It is a process that continues. Remove gravity and the planet would not continue orbiting. It would fly off in a straight line. When you ask, why does this continue? You must first determine whether you observe true persistence, which needs no explanation, or continuous change, which requires continuous conditions. The flame continues because fuel and air continue to be present. Remove them, and the flame ends. The orbit continues because gravity continues to act. Remove it, and the orbit ends. The stone continues because nothing opposes its rest. It would continue just as well if you forgot about it entirely. This distinction prevents endless confusion. It reveals where effort is truly needed and where persistence takes care of itself. And yet, for all we have understood, we must end with proper humility. We have established the laws by which bodies move. We have unified terrestrial and celestial mechanics. We have demonstrated the universality of gravitation and the equivalence of motion and rest. These achievements are real, and their power is vast. But we have not explained why these laws hold. Why does gravity act at a distance? By what mechanism does the sun reach across 90 million miles of void to pull upon the earth? How does matter know that other matter exists and where it is located? The effects are manifest, the causes remain hidden. I frame no hypothesis. The effects we can demonstrate, the mechanisms we can only name. Gravity acts according to precise mathematical law, but how it acts, why it acts, remains beyond our current understanding. We have found patterns in nature. We have not found ultimate explanations. This is not failure. This is honesty. We have mapped a portion of the great ocean of truth. We have found pebbles on the shore, smoother and prettier than common pebbles perhaps, but pebbles nonetheless. The ocean stretches beyond, vast and undiscovered, awaiting those who come after, with sharper eyes and more patient inquiry. Return now to where we began. The cart rolling to stillness, the ball falling back to earth, the ship drifting to rest upon the water. You saw these before as motion returning to its natural state. Now you see something else entirely. You see resistance overcoming motion. You see gravity altering direction. You see friction claiming speed. In each case, you witness not the expiration of motion, but the imposition of change. Change accomplished by forces that were always present, always acting, merely unrecognized until now. The cart does not stop because rest is natural. The cart stops because the stones beneath it push backward against its wheels with every rotation. Remove the stones, smooth the path, empty the air, and the cart proceeds forever. The ball does not fall because rest upon the ground is its proper place. The ball falls because gravity, the same gravity that holds the moon in orbit, pulls it downward. Absent that force, the ball thrown upward would continue upward eternally, never slowing, never returning. The ship does not still, because stillness is the natural state of ships. The ship stills because the water resists its passage. Place that ship in the void between stars, and it would sail on to eternity. You have been living in a world where invisible forces constantly impose change, and you mistook that constant imposition for natural law. You believed rest needed no explanation because you could not see what maintained it. You believed motion was unnatural because you could not see what opposed it. Now you see. Motion and rest are the same state, viewed from different frames. Neither requires cause. Neither demands explanation. Neither is more natural than the other. What requires explanation, what demands investigation, is change, and change alone. Every alteration of state points to a force. Every persistence of state points to nothing at all, for nothing is required. The universe does not ask why things continue. It asks only why things change. In this question, properly posed, all of natural philosophy begins. Close your eyes for a moment. Sit perfectly still. You perceive yourself at rest. But you rest upon a planet rotating at hundreds of leagues per hour, orbiting the sun at vastly greater speed, carried through the cosmos by motions you cannot feel, and speeds you cannot fathom. You are moving, have always been moving, yet you perceive perfect stillness. This is not illusion. This is the deep equivalence we have uncovered. You sit within a ship sailing through the void, and no experiment you perform can reveal your passage. The universe does not distinguish between your motion and your rest. for there is nothing to distinguish. Both are the same state. Both persist without cause. Both change only when force compels change. You have always been part of this motion. You have always been governed by these laws. The forces were always there, the reciprocity always operating, the gravity always reaching. You simply never saw it. Now you do. The cart rolling to stillness, the ball falling to earth, the ship drifting to rest. These are not motion returning to its natural state. They are change, imposed by forces that operate according to precise law, predictable and calculable, the same law that governs the moon and the tides and the paths of comets across the sky. What moves the stars moves the stones. What governs the fall of an apple governs the orbit of Saturn. There is one physics, one set of laws, one unified system of nature, and you stand within it, part of it, governed by it, capable of comprehending it. This is the key that unlocks the machinery of the cosmos, and the great ocean of truth lies undiscovered before us still, awaiting those with eyes to see, patience to inquire, and the wisdom to ask the right questions.